folks. Welcome out there. It's Mathline time. I'm Ernie Roberts. I'm your host for this afternoon's session. We're glad you've tuned into us. A little dreary afternoon here in our area. Rainy, cool outside, so that makes it a good time for you to get cozy in the TV room. Let's watch some Mathline, enjoy, relax, and unwind, okay? And learn some math. By the way, in addition to watching, call us, all right? That number, 844-686-2378. We would love to hear from you this afternoon. It's a Thursday afternoon. We're going to be live for the rest of this half hour. And next week, we'll be back again. But tomorrow, Friday, specialized segments. So my point, strike now while you can get to me, all right? Give us a call. We got operators waiting to take care of you. Again, that number, 844-686-2378. And to see what we got going here, let's go ahead and warm up with the problem of the day. We've got a little sequence going on here. It says, give the 10th term of the arithmetic sequence 40, 32, 24, and run. It keeps going. Now, arithmetic, that's an important versus the word geometric. So let's look at this problem. Let's see what the key word is all about, what that arithmetic is. That means, folks, when we have an arithmetic sequence, that we are going either up or increasing by the same amount, or we're decreasing by the same amount as we move down the scale. So in this case, we're going down. So we're going to think about this as a distance or a difference each time. Looks like 8, because the distance has to be constant. Can't move it, change it, then it becomes not arithmetic, okay? It may have some other kind of sequence or some other meaning out there, but it doesn't fit the definition of what we have for arithmetic. So we're looking for taking the same number, subtract, all right, until we get to the 10th term. Now, let's look at this just a little bit. We're going to look at a couple of ways. First of all, we're just going to crank out on it. And I say crank out on it because it's not a hard problem to just list 10 numbers. Now, if that were the 20th or the 30th term, we'd all be going like, what do you want us to do that for? All right. And is there a shorter way? Yes, both of them. All right. So let's take a look at this. We start with 40. We'll move down to 32. How about it? Got 24. We already knew that, right? What comes next? Subtract 8 from it. I'm going to 16. Keep going. Keep dropping the 8s here. Down to 8. Whew, hit 0. Now life gets interesting because we're going to cross where? Into negative territory. So thus far, that's our 6th term, by the way, all right? So we're looking at our 7th term. Looks like it's going to be, negative 8. How about negative 16? How about running into my picture here? Negative 24, and I'm going to drop one down right here. How about it? There's number 10, negative 32. That's one way, just to crank it out. And with the number 10, that's not that hard to do. But yet, you can still make a little error or two in there probably. It's not foolproof, but it works pretty well for that size of a term that we're looking for, the 10th term. Now, what I was saying, is there an easier way to do it? I think there is. A formula type situation. Let's talk about it. And it's basically saying if we're looking for this nth term, which in this case is the 10th term, we'll get there in just a second, equals to your first term. I'm going to use that little a there just to distinguish that we're looking at a different thing. Okay, this is term. This is basically the nth term. You could have a little a there also. It's really not a big deal here. What we're going to look at here, however, is the fact that every time we are dropping, so we're adding a d, which is our distance. You say, well, Ernie, I thought we were dropping. Well, we will fix that in just a second, all right? And the formula says, let's go with that n, and let's subtract 1 from it. Now, people always wonder, why do you subtract 1 from it? All right, this is my question. Algebra 1 kids ask me when we do this in Algebra 1 for the first time. Some of our 8th graders are saying, well, we can write it out, but how does that formula, why does it change? Well, because remember, you're already giving the first term. So what you're looking for is what's the difference as you go 9 more. That's what n is 10 here, right? So let's go ahead and define what our numbers are going to be here. Our A1 is equal to 40, by the way, folks. That's the first term. That's all it is. This is A1, all right? No magic there. It's just where we start. The next piece of information that we got is that difference. And we've already established we're dropping by 8 each time, so that's a negative 8. So hint, we're going to put a -8 in there, and that's going to change that plus to minus. It's going to be nice, okay? Everybody gets excited. Happy, happy, happy. Yes, yes, yes. And again, like I said, this little n-1 business is because we're going to look for 9 more terms to get from that first one. All right, you've already picked up the first one, so you get 9 more to work with. That's why we use the n-1 format there. So make it easy on yourself. And this little guy here, it could be anything we wanted to. I could put term, but let's just go ahead and do it, all right? I'm going to change from big A, I'll go to little a, all right? So the 10th term, 10th term, that's nice, is equal to, what we got? Plug in the formula, 40 minus 8, that's our D, all right? Times, we do know what n is, don't we? How about it? 10 minus 1, and let's see what's happening. I got 40 minus 8 times that 9. And there we are there. Thank you, guys. And once again, coming to the rescue. Now, what are we looking for? We're hoping to get to the -32 there, all right? See what happens. This gives us 40 minus 72, which will get us to -32. So there's your story. Either way, cranks out. You can get there. That formula is a great thing to have under your belt, okay? Works out very well. So there you have it. Problem of the day worked out basically. Crank it out or think it out, all right? You can do both. And that's the start. Thinking of thinking, speaking of cranking, press those figures, press those digits. Get going here. 844-686-2378. Hit your phones and let's see if we can get some callers going on. I understand, I think I have a caller waiting for me. And yeah, and also while we're at it, we think about Facebook. Don't forget, we do like it when you love us there, and this problem of the day was there, and I have a feeling some of you probably answered it today on Facebook Live. And once again, it's www.facebook.com/Mathline online. Like us, love us, and above all, share us, okay? And understand I have a caller waiting for me, so let's get to that caller here. Welcome to Mathline this afternoon. Who am I talking with?
My name is Gina. How are you?
Gina, doing well, thank you. How are you doing today?
I'm doing good. I am stuck on a calculus problem, and I was wondering if you could help
me.
me.
Let's see what we can do. We'll see if there's a way to get out of this thing, all right? We'll see if you've got, I don't have a book in front of me. Sometimes that's where all those rules come from and such, but let's see if we can find things together. How's that?
Okay.
All right.
The problem is y equals e to the x over x.
Okay.
And I'm needing to find the relative min. I found the max, which doesn't exist, but I cannot find the min.
Okay. So what is what's the process you're wanting to do to find? Let's go first of all. How did you work to finding your max? Did you run a limit?
I took the derivative of that, and I found that it does not exist.
Okay.
That I cannot find the min.
Okay. So what we're looking at here, how far? In other words, how low? What can x equal? I'm already thinking one thing we can't have x equaling to would be 0. And do you see why I'm saying that?
Yeah.
Because we're going to get a 0 in the denominator, which will make this become undefined also. So
yes.
in my thought here, I'm wondering if it has somewhere around that possibility of approaching to x equaling 0 there. So what did you use for your derivative? Let's go ahead. Did you use a chain rule of some sort there?
Yes. What I got is e to the x minus e to the x over x squared.
Okay. So basically, you went ahead and used the derivative of e to the x, which is e to the x, right?
Yes.
All right. And then where did we come up with the x part here? Times just the...
That's just what my teacher, that's how she showed it.
Okay. All right. We're going to go with that. And then on the other side, what did you have again? You had e to the x.
E to the x, then it's all over x squared.
Okay. Because basically we're going to multiply there by 1 over x squared, which is the derivative of 1 over x. Am I right on that?
Yes.
And that's also how we got that minus in there, folks. That's where that came from, if I'm not mistaken. So am I good on that? Because it's like taking x to the minus 1, so we take the derivative of that, okay? And so that minus 1's kind of worked out its way there. All right, what I'm kind of looking at here is wondering if we can look at a GCF moment here, you've got an e to the x. I'm going to try this. And I'm going to also say, let's see, what happens if we were to take out, let's see. We could also pull out, let's see what we got first. X minus 1 over x squared. Do you see where I'm going on this?
Mm-hmm.
I got an e to the x going here. And then maybe I can look at this a little bit easier, because what this is going to give me, I'm looking at e to the x. I'm playing with this because I would love to see kind of the guidelines that you've got going there. But I'm looking and I'm seeing that I can put this over 1, and I've got an x squared here, and that should give me what? X squared minus 1 over x is what I'm looking at. And the thing, no, it isn't. It's going to be x cubed, isn't it?
Yes.
So my thing is, I'm wondering if, in this case, looking at this expression up there, to get to a minimum, I'm thinking maybe look for 0. Because if you put a 1 here, in other words, let's get this thing to go to 0, okay? My possibilities here, if x equals 1, what happens here? I get 1 minus 1, which is going to give me what? 0. And I still have it over 1, okay? And over here, I've got e to the x, but guess what happens when you multiply that into the 0? It's going to still go to what? 0.
Sure.
So in my mind, that's kind of what I'm seeing. And again, the process, that's my thought. This would factor. This would factor out also. It'd be an x minus 1 times some crazy stuff out there that would not be factorable. And that may also open up some ways to use a quadratic formula. I think you'd have, if you did this x cubed minus 1, I'm trying to think in my mind, going back to a little algebra 2 here. I believe you're going to get x squared. I'm thinking maybe you get plus x plus 1 on the end. Seems like something like that. I know it's not plus 2x there, but I want to say it's something of that nature where you're multiplying through there. I can't remember exactly what that formula. Does that make sense? You remember that?
Yeah, the ax plus bx plus c.
Okay. And yeah, and there then you might be having a situation where these get some roots in that regard. And I'm still trying to think if this is going to bring us, that's going to get us back to x cubed. That's going to get us to the minus 1. I'm thinking that's going to get that's the way it would work to do that. So it could be coming from this thing. You got a 1 value for x, and over here you're going to get some, as I said, using the quadratic formula, you'll get kind of some crazy square root type situation. So that's where I'm kind of looking at to give us a minimum that makes this thing go to 0. And there again, it could. Does that make a little more sense? Does that make sense to you? What I'm trying to do?
It does. That's what I was thinking. But everything that I try to plug into it when I go to put the answer is telling me I'm doing wrong. So I'm trying to figure out what I'm doing wrong.
Well,
to get
as I said, my thing here, the e to the x, you've done your derivative. You've done your derivative fine, okay? From what I can tell, I believe you're okay on that. And then from there, it's just a matter of getting it to that, down to that. I find this simplified form here, and like I said, x cubed minus 1. I'm using a little intuition on it at that point. So, and another thing you might try to do is put this thing. Do you have a graphing calculator? Maybe pop it in. Let's see what it looks like on the graphing calculator here. I'll take because there's so many times that helps a lot is to see the picture. Now I see e to the x right there, and I need to put an x on it. All right, then let's get it over a little bit. And what do we have? Divided by, right? Divided by x.
Divided by x.
And again, there again, we're looking at the actual function itself rather than going to the derivative. Understand that? You got me on that? So
Up there by alpha.
yeah, I just want to, this way I can, at least we can see how it's behaving. What's this crazy thing doing? Okay, and there's where and see things are happening. It looks like at x equals 0. You're going to that undefined moment, okay? So that's where I'm seeing a relative minimum. It looks like at x equals 1. and it's bouncing up and giving me, that's for the regular function. So that's where I'm thinking maybe that's what we're looking at.
So
That's where where I picked up. Well, it looks like x equals 1, but what's your value of y there? You would go back into your original equation. Maybe we can hit a trace here and see what it gives us. Trace, put a 1 in. And in your original function, basically it's what's e to the 1. That's your e to the 1, or just e, value of e. That's what I'm seeing there. And that's my idea of a relative minimum, because over here, we really don't have, you see, we don't really have a minimum.
Right.
It's just a smooth curve. There's no bump. That's the only thing that looks like an inflection to me. So does that help something? Now you can kind of see what it is, and
it does.
then ask your teacher what goes along with that. But I'm betting on x equals 1. Okay.
Okay.
That's what I'm thinking.
All
Hey,
right,
thanks for calling. Thank you for calling. Making me think on a Thursday afternoon. I understand we got another caller waiting. So welcome to Mathline. Who am I talking with this Thursday afternoon?
Emma.
Hi, Emma. How are you doing?
I'm doing good.
Good. I tell you what, if you listen to me, I know you're trying to pay attention on the TV, but just kind of tune it out basically and talk to me, and you'll see me writing and stuff there. So that way we don't have a lag time, because we're getting a little bit of lag time waiting to talk. Okay? Does that make sense?
Yes, sir.
Okay. Thank you. Where are you calling from, Emma, by the way? What city? What county? Can you tell me?
Tennessee, Jefferson County, New Market.
Absolutely great. Jefferson County, Tennessee. I love that. You're not too far away from where I am. I'm down here in Knox County. So what can I do for you this afternoon? What kind of problem you got for me?
It's S divided by 7 equals 12. Solve for the variable.
Is it S or X, or it doesn't really matter? It's a variable, right?
It doesn't really matter.
I'm going to put an S, and you said divided by 7?
Yes.
Equals to 12.
Yes.
Okay. Now, what we're looking for is a number that obviously you hope will be bigger, right, than 7 or 12,
Yes.
because you're dividing it up into, 7 pieces, and you're supposed to get 12 in each piece. That's what basically is going on here with this problem. So let's think about it. How would you undo division? How do you undo a division?
Multiplication.
Multiplication, absolutely. So what we're going to do, and I'm going to do this as best I know how to do for you. I'm going to show that we're going to multiply by 7, and I'm going to put over 1. Makes it, since we got a fraction going here, I'm going to put 7 over 1 right there. You see what I'm doing?
Yeah.
Okay. And while I'm at it, I'm going to drop a 1 under that 12 over there. So I know that it can be a fraction. 12 over 1.
Yeah.
Now, I bet your teachers told you, I hope they have anyway, if you do something to the left-hand side, what have you got to do? You've got to do something to the right-hand side.
Right-hand side.
And it's got to be the same thing. You can't decide, but let's do something different, okay? So I hit this side with 7 over 1. I like 7 over 1 over here, okay?
Yeah.
Does that make sense? And
Yeah.
you know why I did that? Because we're going to say goodbye to those 7s, which makes life a lot easier. I've got my S or X or whatever value we want to call it there, variable, equaling to, I got 12 times 7. Does that make sense to you?
Yeah.
And 12 times 7, I believe, is 84. And you know me, I always like to come back and say, does it compute? Does it check? So we're going to go back to, we're going to take this number we got here, and we're going to see what happens when we put it in here. So I'm going to put that 84 over 7. And do you get 12 out of that? I believe you do, right? So there's your quick check. And you can do that mentally and so forth. Does that make sense what we did over here?
Yeah.
And another way you could write this, your teacher may like you to write this, is just simply say you're going to have S equaling 12 times 7. I like to show this. I really do. I like to show where the cancellation's happening, because basically you're removing the fraction out of there. And that process is going to come real handy. What grade are you in?
7.
7. That's going to come in real handy when you get into Algebra 1 and Algebra 2, and you start getting some not so pretty fractions there, but you start thinking, hey, I can make things cancel out in doing that approach. And as you said, just reverse the operation. You started with division, we'll multiply both sides to clean it up. Does that work?
Yeah.
And by the way,
I'm in pre-algebra right now.
are you okay? So you're probably getting to the point where you're showing the work there. And in some cases, your teacher will say, okay, you've got this down. Now we can just go to 12 times 7 and move on. Okay, but for right now, I like showing the intermediate steps, especially in my younger students. And once we get to this point, then you got it. You start doing some of those things in your head. Okay, does that work?
Okay.
Hey,
Yep.
thank you for calling us today from Jefferson County, and appreciate it. And folks, that's all it is. That's how easy it is to do. We've got a couple of callers who have led the way this afternoon. So go for it. Give us a call at 844-686-2378. We love to hear from you. And seems like Thursday becomes our busiest day around here. I think everybody's gotten back from the election days. A lot of you had days off from school and all that. So it's good to have some good calls coming in. We had one or two yesterday. Speaking of which, I want to go back to one that we did have yesterday. I believe it was from Lily here in Knox County, and she basically gave us a situation here. We had an isosceles triangle, and I'll make it look isosceles in a minute. It was also a isosceles right triangle, and we were told the hypotenuse equaled 12. And when we drew the picture of it, I even brought Curious George in for the run, and we'll do it again. We just kick it out here real quick. And isosceles, by the way, isosceles means the two legs are the same, by the way, folks. And then we had 12 here. And we did a Pythagorean moment on it, and that was fine because that was good for that person, that they understood it, what we were doing. But we had this situation where it's A, and we had a C there, all right? And we said basically the hypotenuse was equal to 12, as I recall. And what I want to do is I want to show another option to get to A. We used A squared plus A squared equals C squared. And that's fine. But remember, dear friends, when it's isosceles right, we have what we call the 45-45-90 triangle going on here, all right? And what we can do there is there's many formulas that we find, especially when we get into geometry classes. We've got C equals A times the square root of 2 here. We've got C equals A times the square root of 2 because that's the relationship you learn about this situation. You simply put a 12 in for your C, and now, my friends, we're going to divide by this square root of 2. And now we get to that point where we think, oh, okay, that's a formula, by the way. That's a formula that we learn when we're working with 45-45-90s. There's also the 30-60-90s, which have special formula also. But this is where we go. Now, what is 12 divided by the square root of 2? And some of you are going like, whoa. And here's where we get the quick going. We want that square root of 2 out of the denominator, all right? So we're going to multiply. We're going to rationalize that denominator, we call it. And we're going to run a square root of 2 into the numerator. And my friends, here we go. 12, square root of 2, all over 2. And now we have 6 square roots of 2. So that's another option. It's another option to clean out. And I want to tell you something. There's a little secret. I call it divide and attach. When we got a whole number over a radical, all you have to do is say 2 goes into 12. If it's a square root radical, let me put it that way. You can simply divide by that 2 into 12 and attach. So in other words, 2 goes into 12 6 times, bring that root of 2 up for an attachment. It'll work every time if you've got a square root here and this little guy likes to go out even, all right? Hey, if that little guy doesn't go out even, you're going to have like, let's say it was 13 for some reason. 13 square roots of 2 over 2 still works the same way. So here we go. This is the side. And then she asked about perimeter and all those good things. Works out pretty well, okay? So they worked through, perimeter was 2 of these, which would be 12 roots of 2 plus 12. And the area, as I recall yesterday, I don't know if I remember what it was. I believe it was 36. I think that was right for yesterday. It'll still be the same thing. I understand I have one more caller waiting. Let's see if we can get them in, all right? Welcome to Mathline this afternoon. Who am I talking with? Are we there?
Joseph.
And who it is again?
Joseph.
Joseph. How are you doing today, Joseph?
Good.
Good. Where are you calling from, by the way?
Maryville, Tennessee.
Maryville, Tennessee. All right. What I'm going to tell you to do is I'm going to go ahead and let you give me your problem, but I'm going to have you to stay on the line, okay? And we'll probably need to work it because the show's about to end and I have to close out and all those good things. But what's your problem for me? Go ahead and let's see what we've got. Let's see if we can work with it.
In an isosceles triangle ABC, the equal angles at B and C are each 50 degrees. The sides of the triangle each touch a circle of radius 2 centimeters.
Okay.
Calculate the length BC.
All right, so you got an isosceles triangle with 50 and 50, and guess what? That tells me the other angle is going to be at 80 degrees, right?
Yeah.
Okay, so now what's going on with our circle? We have a circle you mentioned.
Yeah.
And what's the story on it? How is it working? Is it inside, outside? Where is it hanging with the triangle?
It's on the inside of the isosceles triangle.
Okay, hey folks, we're about out of time. We will be back again tomorrow, specialized segment. See you then.